Now that you've become an expert with each of these characteristics of a polynomial graph, let's test your knowledge with these class practice problems. Of course, you should have tried these problems before watching this video. That is what students would be doing in class. So, the domain, everybody's favorite, the domain, always has to do with the x values on the graph. Now, the two circled values that I have shown represent how far the graph can go to the left and how far the graph can go to the right. So notice that I'm using those two extreme kind of points, those two endpoints, to say that I can go between negative 2.5 and 1.25. Of course, those would be those x values. How about the range? The range would be the y values on the graph. Notice that I'm looking at how far sort of the graph can go down and how far the graph can go up. With these two circled y values, the graph is between negative 4 and 4. That is, every y value is between negative 4 and 4. Extrema. Extrema always have to do with like maximums and minimums on the graph. So let's see if we can classify some of these extrema. Negative 2.5 and 4 is definitely the highest point of this graph. Therefore, it is the absolute maximum. It is the highest point on the graph. Negative 2, 0, negative 2, 0, that's a low point on the graph, but it's not the lowest point. It's just a low point, so it's a relative minimum. There's some other points on the graph that represent extrema. How about the point negative 1, 2? Negative 1, 2 is a high point on the graph, but it's not the highest point. So we call it a relative maximum. How about the point 0, 0? How about the point 0, 0? That looks like that's another low point on the graph. It's not the lowest point on the graph, so we would call that a relative minimum. But it is a low point of the graph. How about this point right here? It doesn't look like it's right on an x value, but we'll say it's 0.75, 1. It's definitely a high point on the graph. It's not the highest point, so that's why we're going to call it a relative maximum. And then the only point that we haven't discussed is this point at the bottom. It is, notice at the bottom, it is at the very bottom of the graph, and that's why we're going to be able to say that 1.25, negative 4, is an absolute minimum. It's absolutely the lowest point on the graph. Extrema, high points and low points on the graph. How about increasing and decreasing? Increasing, remember, means that the graph is going up. Decreasing means that the graph is going down. Now what I'm going to do is I'm going to highlight the parts of the graph that are increasing, that are going up. If this was a roller coaster ride, we would be going up in this interval. We would also be going up in this interval. So between these green points, the graph is increasing. We just want to correctly identify those points. And when we do this, we want to only use the x value, because x values always signify a location. So my graph is going up when I'm between negative 2 and negative 1. Now notice that I wrote that as negative 2, negative 1, but that means I'm between negative 2 and 1. It looks like the graph is also going up between x equals 0 and x equals 0.75. So again, when I'm between 0 and 0.75, the graph is increasing. Now the graph is decreasing when I'm going down. If this was a roller coaster ride, I'd be going down in these 3 red regions. But whenever I give a location, I always want to give it as an x value. So what's the x value of sort of these two endpoints? Well, they both were already given, but to highlight them again, This x value is negative 0.25, and this x value is negative 2. So the graph is going down. It is decreasing between negative 0.25, excuse me, I said it right but wrote it wrong, negative 2.5 and negative 2. So the graph is going down. Oh, I did write it incorrectly here. Yeah, negative 2.5. And then it looks like the graph is going down between these red points. What are these red points? Well, I already gave them. They're x equals negative 1 and x equals 0. So we're decreasing when we're between negative 1 and 0. And then finally, one more time, we're decreasing between these red points, which again, I use the x value to signify. That's why we're going to say between 0.75 and 1.25. Increasing, decreasing. It just means that you're going up and down. But you want to use the x value to describe those locations. Roots. Roots are when the function is equal to 0. In other words, when we're on the x-axis. So the function is equal to 0 at these 3 blue dots. All I got to say, I just got to say so. So when I'm at negative 2, 0, and 1 are those 3 blue dots. The roots are when the function's equal to 0. Positive and negative. Positive and negative, it just means that the graph is either above or the graph is below. Now be careful, to be above and below is different than increasing, decreasing. I'm going to highlight all the parts where the graph is above, where the graph is positive. What we want to do is we want to just say so, which is between these 2 green dots. Notice that again, I'm using the x values to describe that I'm between negative 2.5 and 1. Now, sometimes students will say, but wait, how about these blue dots? I thought these blue dots I was equal to 0. Well, technically, yes. When you're at those blue dots, you would not be greater than 0, but you'd be equal to 0. So we can give like a little disclaimer. We can say when x does not equal each of those 2 blue dots, negative 2 and 0, but that gets a little bit extra, and I'm not necessarily requiring that. I do want you to make sure that you know the graph is positive in the green region and the graph is negative in this red region. So we just need to say that we're negative between these 2 red dots. Again, negative means that we're less than 0, and so between those 2 red dots would be between 1 and 1.25. And finally, evaluating. Evaluating means that we're trying to find y values. We're basically just trying to find y values for the given x values. Now these are all x values, so this would be like x equals 1, and I just need to go over here to the graph to x equals 1, which happens to be right here at this red spot, and say that the y value right there is 0. How about x equals negative 1? X equals negative 1. X equals negative 1 would be right here at this blue dot. I just need to give the y value, and the y value right there is definitely 2. So that means f of negative 1 equals 2. How about some more y values? The y value at 0. The y value at 0. That means when x equals 0, that appears that it's also 0. That is, the y value is 0. What about if I'm combining different x values? Well, it simply means that I want to just find different y values, and then apparently I'm going to subtract them. So I need the y value at 1.25. Now the y value at 1.25 is negative 4. I also need the y value at negative 2.5. Well, that y value is positive 4. So it looks like that this problem is actually trying to get me to subtract negative 4 and 4, which comes out to be negative 8. And finally, we have a multiplication problem. We're just gonna, this dot is really not, this dot is a little bit confusing here. Let's kind of erase that. We're gonna multiply. It looks like I'm gonna need to find f of a half. That just means that x equals a half. So I'm gonna go to x equals a half on my graph. X equals a half is right here. And what do you think that the y value is right there? Does it look like the y value might be 1? I think it's good enough. So we can say that this is going to be like taking 4 times 1, which comes out to be 4. So evaluating, it's really just finding the y values of each of those x values. How about class practice problem number 2? Let's just kind of run through this a little more quickly now that we've seen all these answers. So we've got a graph that it would have arrows on the ends. It really should be shown that way, but I forgot to put that there. So we've got arrows on the end. The graph goes to the left and to the right forever. It also goes up and down forever. And since it goes to the left and right forever and up and down forever, our domain n range is going to be negative infinity to infinity, again, for both of those. Increasing just means the graph is going up, and I know there's arrows on the ends, but you always want to be thinking about what the direction, what the graph is doing as you travel on left to right. It's actually going up all the time. So it's going up, it's increasing. Oh, wait. That's supposed to be the extrema, but I just talked about the increasing. Well, if it's increasing all the time, it's never decreasing. Again, don't tell me that this arrow right here means that it's decreasing. It's never decreasing. Speaking of never, there's no extrema. There's no point on this graph that represents like a high point or a low point. This is not a high point or low point, neither is this, or even this point in the middle. There are no extrema on this graph. There's no high or low points. The root is supposed to be when the graph is equal to 0. Oh, that would actually be that only green dot, that lone green dot when x equals 0. And then to be positive means that the graph is above the x-axis. So that's right here, but to be negative means that it's below the x-axis. So we're positive everywhere to the right of 0, 0 to infinity, but we're negative everywhere to the left of 0. That would be positive and negative. And finally, we have the opportunity to try to draw a graph. We're going to draw a graph that possesses each of these characteristics. Now, one thing we want to realize here is that if f of x is equal to 0 at negative 4, 1, and 3, those are roots. Those are roots. So those are going to be x-intercepts on the graph. I can actually draw them or plot them right now. How about f of 0 equals 1? That's just a fancy way to talk about the y-intercept. The y-intercept is always when x is equal to 0. An absolute maximum at negative 2, comma 4. Well, negative 2, comma 4 is going to be somewhere in this vicinity, maybe even a little bit higher. So it looks like that's going to be a high point. We also have a relative maximum at 4, 2. 4, 2 is going to be like right here. A relative minimum at 2, negative 1. 2, negative 1, probably about right there. Now, it says that f of x is less than 0 when x is to the left of negative 4. What that starts to represent is that the graph is going to be negative. That means when I'm to the left of negative 4, my graph is going to be down in a negative area. But my graph is going to be positive when I'm between negative 4 and 1. Okay, so between -4 and 1, my graph is going to be positive. That means it's going to be above the x-axis. But between 3 and 4, or I should say, and between 3 and 4. So we have a positive graph in both of these places. Get rid of that little plus sign. Finally, it looks like that the graph is supposed to be increasing. That is, the graph is supposed to be going up between -infinity and -2. Well, that looks good because my graph is going up all along here. So that looks good. And then it says the graph also should be going up between 2 and 4. Now, if my graph's going to be going up between 2 and 4, I got to add an extra line in here so it can go up this whole time. Oops, let's keep that line there. And then it's decreasing between -2 and 4. That means the graph is going down, between -2 and 2. So I got to add an extra line in here so that it can go down. It looks like there might be a little bit of a typo because this region right here is also negative. And so I feel like there should be 2 negative regions. So we will have to add that in. And we end up with our graph that has this basic shape to it. That's a little tricky, but basically it's trying to analyze each of these given characteristics.